Hello everyone. It's a pleasure for me to be here. It's a pleasure to me to join the event, and it's a particular honor to be here also as both a presenter and a representative of Anthill, and which is the company that pretty much stays behind some of those things I'm going to explain today. Today, we'll talk about advanced grid automation. I like talking about wires. I like talking about how you can take a physical project, how you can take a physical object and pretty much use the power of Azure, Power BI tools, IoT Hub to achieve something quite astounding, even in Bulgarian. Thank you for all the sponsors. Thank you for the organizers of the event. And I'll just switch to the presentation. The reason I like to talk about grids, something quite mundane, something that we used to find as quite ubiquitous, is that nowadays we're not facing the usual process of generating the power and basically distributing the power and using it, but we have a multi-directional of power and data. That is mainly because we have so many new things like renewable energy, electrical cars, new ways of optimizing energy efficiency, energy storage, and also the increasing pressure of how to make it all quite more competitive and cheaper and more secure. So basically, this multi-directional flow requires a super comprehensive look on how the whole ecosystem operates. And lately, in the past 5 years, it evolved so badly that it now cannot be comprehended by the use of human minds. And this is why, thanks to the development of artificial intelligence and machine learning algorithms, we've started making simulations, and we started talking about a new basically, phenomena that appeared, which we refer to as the digital twins. The digital twins is something that's been relatively new. The tools, the processes, the knowledge, the experience, the experts, they don't really have a lot of experience to draw upon, and we're still in the exploration stage, and we're still trying to figure out what is the right balance between cost, technology, what are the advantages, and basically now we sit behind the understanding that it's not only clear to understand the nature of the assets and how different elements of the asset intercorporate with each other, but also how those things relate to each other, not only on the level of a single object, but also how do they interconnect with all kinds of different items and objects and events, so we can not only track how they operate, but also predict how this will happen in the future. And again, the reason for that is, I'll just give you some example. One big challenge that we're facing today is, for example, the advent of electrical vehicles. Because by 2030, which is less than 10 years from now, the number of electrical vehicles, for example, is expected to grow from about 5 million, what we have today, to more than 125 million. And the problem with that is that if we don't have a very good prediction analysis on how it's going to work in the system I'm just showing on the screen, it will simply kill the existing system. For example, if they charge at the same time, it will just destroy the grid. And also the construction and operation of a lot of those, I'm just giving a single example, of a lot of those charging stations is very capital intensive. And for example, we're not only, we don't know for sure where we need to put them, what will be the usage. So it's kind of an egg and chicken dilemma, which, we're struggling to figure out how to do today with modern IT tools. So to meet those challenges, the comprehensive electrical utilities, they need a very unified, comprehensive view, pretty much how the network behaves, plus how to address that in a way that we as consumers are willing to pay for this. Meaning that the regulator and competition pressures should have to be taken into consideration. So this is where the role of the Power BI tools comes into place. So taking this huge complexity also requires a very robust way of explaining and visualizing that. So one of the problems that you see on this map is it involves so many departments, for example, network maintenance, network planning, GS department, IT, they all have super specific views on how the grid should operate. So basically, the problem with that is when we come to a typical representation of how a power generation and transmission distribution operates, we come to the problem of silos, data silos. And those data silos cannot be easily, experimented with, because one of the problems that we see is that you can't simply take it and rework it, because otherwise you have the challenge of basically killing the grid or creating some disturbances that are unacceptable. So this is an example of an asset where on one hand we cannot continue making manual data sharings because we're just simply inefficient and we're facing a future problem that can kill the grid. At the same time, though this asset valuation and the interconnection of different assets cannot be proceeded to be done manually. So we require, to figure out what will be the mix of analytics, machine learning tools, and and basically how to connect that so it basically doesn't destroy the system. The point of that is, again, increased efficiency, productivity, optimization, but also the mere survival of the grid depends on how we apply those tools. Right now, this is the current mode of operations. The main focus, what I've seen in electrical utilities, is quite traditional. So you have a traditional hierarchical dependence. It's a parent-child relationship. For example, we have a cooling unit with that is in specific fixed relationship with the specific pump. The problem with that, it can operate quite well to, for example, predict when do we need to change the pump based on a normal cycle of operations. But when it comes to a more complicated environment and also some events like, I don't know, like bad weather that will affect the product life cycle, it's almost impossible to predict in a rigid structure. So question today is what is the experiment and what tools we have and what is the way to apply AI predictions in a way to fix things before they break, or plan for events that can happen, which we can try to simulate so we know how to react. Now, the prediction is super important because we need the insight into diagnostic information, not only what had happened on historical reasons, but what can happen based on information that even did not happen. We don't want to end up in not being able to use electricity, because this is something that's a lot of people claim as super important for the survival of humankind. We want to be able to experiment safely in a way that will allow us to take into consideration things which we cannot even imagine. So this is the role of what we refer to as digital twins. So digital twins is basically that will enable us with a model that learning models can be combined for better predictivity and without jeopardizing the existing modus operandi. So it will not create those problems. One of the things on that slide is that those different departments need to operate simultaneously. And one of the problems that we started facing with digital twins when we're trying to apply to something even as simple as electrical grids, is that we needed a way to find a better model, better approach to apply real-time data. Can be IoT data, can be all kind of different data. But the problem is that in manufacturing, we can take a simple pump and basically analyze it and predict what it can do under a normal cycle of operation. The electrical grids are a super example of something that you cannot control. It's out there in the open. It can be anything from theft to earthquake, and this is to like bad weather, kind of overloads, peak loads, and this again is something that we need a better tooling to predict. To give you an idea of how complex it can be, I'll just give you an overview of what Siemens are trying to build and the multiple data sources and processes that have to be interlinked somehow to enable a real electrical digital twin. So what do we do about it, and where is Azure have to play in this whole field? So what I want to do is something relatively new. The Microsoft Azure Digital Twin concept was literally introduced in 2018, so it's super fresh, and it's being an upgrade of digital twins. We should not confuse it with the digital twins that are being reviewed earlier in the IoT Hub. So the point of the digital twins in something as small as a part of the whole human society as energy is to connect it across the different spectrum and figure out the tools that would enable us to connect to things like healthcare, real estate, legal, education, finance, so we can have not only better prediction but also a better robust model how to create it and how to implement it. The main thing that the Azure Digital Twins enable you is the ease of uploading and exploring models, and the combination of different systems, different databases in a way that basically interconnects and is able to pretty much self-heal itself. And the most important thing of the Azure Digital Twins, which is a platform as a service, is basically it helps you prevent this biggest obstacle to digital twins creation, which is on one hand the silo data across the ecosystems. And why it's important? Because energy utilities have been around for decades, and the problem with them is that very often we need to be able to interact with legacy systems. We can end up in a situation with 5 different databases. We can end up in a situation where we have monolithic systems and architectures that suddenly somehow needs to be connected to new microservices depending on the type of the business application. And we basically have absolutely no way to have the old hierarchical parent-child relationship. Another problem is security, because the more tools we apply, the more cloud computing we apply for not only predicting but also managing this huge complexity. Is how do we address security, which is something that is also addressed by the Azure Digital Twin. One last, there are many challenges, but one last major challenge is connectivity, because a lot of the problems with the digital twins is that they have to be connected to the internet, and this is one problem where if we have bad connection and not precise infrastructural conditions, which is the case with many utilities and many electrical grids, because we're talking about remote locations. This is something that Azure Digital Twin is also able to address. Now, again, the digital twins in Azure Digital Twins are quite different from what we already know as device twins in the IoT Hub, because IoT Hub device twins are basically focused on describing the capabilities and the aspects of the device, while here we're finally talking about more conceptual representations. And so this can take our user-defined insights and basically connect them in new unimaginable way. Again, those insights and the environments could be anything from building, factories, energy networks, railways, and it's super important that we have this open-minded view of how do we connect those things, because at the end we should be able to analyze what is the lasting impact, because electrical grids, that's why I love them, they're not isolated. They just touch pretty much anything that we do. What I particularly like, again, it's a new thing, I just started experimenting with Azure Digital Twins. using the digital twins definition language, it's a very easy way to model any environment in a very scalable and secure manner. Plus, the beauty of that, it connects to Azure IoT, and it pretty much enables automatically to connect IoT devices and, most importantly, existing business system. It has a very robust event system. You can build quite dynamic business logic and data processing. And most importantly, it integrates lovely with Azure data analytics and AI services. So basically, it's also the easy way to explain to what you want to achieve to non-technical business people, especially using Power BI tools. So again, what it needs. So what Microsoft did is they created a digital twin universe where basically they using an open model link language like the digital twin descriptions language, which I'm going to cover a little bit later. You can take automatically any input from any system and pretty much define how you output it and make it super automatic. So once you make a minor change somewhere in the system, it will automatically recalculate. A note on DTDL. So the digital twin definition language. It's a very simple, super open JSON programming language, and it's super actually programming language independent. It's not exclusive to Azure Digital Twins. So the benefits that are that it's super flexible. Basically, it can cover any model, any vertical, and it's something that Microsoft is particularly well known about is having a very limited learning curve, how to learn to model complex relationships in a physical works. Most important, what is from my perspective, it basically finally enables you to create a neural network data structure. So basically, it lets you, it allows your digital twins to employ higher order analytics, machine learning, and conduct complex computations, especially if you have combined access to cloud computing. So you can pretty much optimize your solution to be at any complexity, any speed, using something that's programming language independent and something that is super open and super easy to understand. So it basically takes our human knowledge of the physical world and translates into a common data ontology so you can connect to anything you want. What is important is that a digital twin definition language based data structure is focusing more on not on parental child hierarchy, but it basically offers sort of a neural network that can help you dynamically map the complex relationships between pretty much anything. Instead that we have like the standard relationship, let's say cooling tower and a specific pump, it basically looks at it as a complex system of interconnecting relationships. And then we can, basically, this is the only way in most cases to identify the specific root cause of the problem. And once we apply AI predictions, we can ideally fix things before they break, or we can simulate an event which basically is intended to break the electrical grids, such as, for example, a severe wind snowstorm. And it's like like moving through like a complicated brain in a very similar way. To give you an illustration how it's done in the real world, I'll run a short demonstration. This is actually a demonstration using Azure Digital Twin by a company called Bentley in Korea, and specific application covers wind farm. And I'll continue my presentation. Second.
Operations demo earlier this year. This also involves Azure Digital Twins and iTwin. And what this does is it allows engineers to do sound to monitor and predict right next to the wind farm. This live power produced by each of the live power come from, the live data. Have an Azure Digital Twins. Let's go ahead and see what that will look like. You can see the overall power being passive. And then we can zoom into individual. Values are based on different predictions. Big question though is how it's working. Anytime the machine learning model fails to track the power produced, algorithm or with the turbine. Get more detailed investigation fast. All we have to do actual observe power along machine learning prediction, the power. And with that, we are ready to move on. All we have to do is click on this power prediction. App fetches weather data from a is flying right now. We're simulating the next day's power. That sums up all the features of the app. App brings together the past, the present, and future data.
Okay, so basically, the reason I liked the wind farm example is because it's a very similar to basically our problems which we have with the electrical grid. They're out in the open. You need to be able to connect weather data. You need to be able to connect all kind of material data, and as with the unpredictable nature of wind, we're also, because of the complexity of the grid and a lot of the changed consumers to prosumers, we also have a very comparable picture with unstable power and demand generation. I give you an example. If you have a hot day and you have a lot of people that are pumping up their air conditioning unit, at the same time you have a lot of instability coming from, as you saw, wind farms and electrical grids. So one problem that so far I haven't found, anywhere in my research, an application which we're trying to build in Bulgaria is a predictive analysis based on Azure Digital Twins for better grid management and for demand load balancing. So why the other tool that is quite linked is the Azure IoT Hub. Again, we have multitude of devices, IoT devices, and what we basically have now is a cloud-hosted solution that basically connects virtually to any device. And one of the key important and relevant aspects that IoT Hub helps prevent this silos when it comes to data acquisition. Plus, it can establish a bidirectional communication with billions of IT devices, which is particularly important for the management of the grid. because we need to be able in real time to communicate back to grid reclosures, be able to communicate to the mobile devices of our maintenance crews, and we need to be also able to authenticate every device for enhanced security. This is pretty much already built in the Azure IoT Hub, which underpins what Microsoft is able to do. You don't have to create a super complicated IT structure to be able to apply those advanced tools. So basically, you have built-in device management and provisioning, you have security built in, and full integration with things like Azure Event Grid and serverless compute, basically that simplifies IoT application development and can link up pretty much anything you already have, including legacy systems. When it comes to those challenges, especially in the electrical grid, Azure IoT Edge is a very, very, very nice decision to address challenges like intermittent access to internet. So it has built-in options for buffering, device telemetry. You can use it to update remotely devices for targeted deployment configurations, and it has a built-in hardware security manager, which you can basically create and replicate common policies across your network. For example, the network we're exploring right now in Bulgaria, on the territory of one of the utilities called CEZ, we're talking about 16,000 kilometers of middle voltage power lines, 20 kilowatt power lines, and some of it has already been automated, and some of it has already been upgraded. So the thing is that we can't have proprietary solutions, because until we make the whole of the grid smarter, we'll have a lot of legacy devices and applications which we need a single common way to connect, and also have single system to address security. Again, combining IoT Hub, Event Hub, never been easier. Basically, to connect any data source, it's all you have to do is to identify which digital twin needs to be updated and call in the REST API. The most important thing on that Azure Digital Twins is able to provide is take data, visualize it properly, enable you to model that in a way that gives you the comfort that you're not going to break anything, but also visualize it into actionable insights and actions in a very, very secure fashion. So basically, this is a very typical IoT reference infrastructure, connecting devices, sending everything to IoT Hub, and it's basically a very, very easy way to take complicated, numerous data sources, connect them in a seamless way, and also convince the stakeholders, as the business stakeholders in a utility, which is an example of a very traditional company, very non-IT company, and basically have a story. Why would they give you funds to finance it? When it comes to financing, what again is a huge advantage is the ability to connect all those complicated systems to a complete set of computing, networking, and storage resources, which you can scale down or up depending on your basically needs and the money you have. So it's a very competitive price performance compared to anything that's on premises. And let's not forget, it's also super optimized, not only from cost control perspective, but also from security perspective. So basically, this is the role of the HPC computing, the high performance computing, which basically enables you to define and also predict in advance how much computing power you would need to run your operations without running into costly procurement of equipment that you're not even sure how much of that you will need, and that will require constant operational expenses for updating and securing further. Quick note on how it all connects to what we've been doing. I've been talking in previous events about one of our startups, which is called Powerdrone, which basically connects information on specific grid elements and visualize them using our own platform. So what we do on the level of an object, this is a screenshot from our platform. We're now able to not only visualize what is happening with different elements, but also use machine learning and machine vision to identify, sometimes with almost 98% accuracy, what is the problem with a specific, let's say, power pole. And we've been able now to collect all this data. We have literally hundreds of thousands of objects gathered. And what we are quite interested to do is see how can we leverage the power of Azure to bring them basically to life. One of the things that we started doing is together with another partner company, MYX from Bulgaria, we started visualizing the grid. Actually, this is a screenshot of a small field near Sofia, near the ring road, and I'll basically showcase you in a second what we're able to achieve as visualization. So taking all the power of Azure Digital Twins, we're hopeful to be able to predict what can happen to the grid in a situation of earthquake, snowstorm, overheating, overcooling, strong winds, I don't know, birds migration, thefts, anything. And this is basically where we sit right now. We're trying to upgrade our ability to collect data with drones, visualize it properly, showcase, use the human minds, basically use that to help an individual look at it and with a little bit help defining what is probably can be the problem. We're helping electricians take an informed decision where they need to concentrate their effort, and if needed, they can do basically this. Let me actually share this. I'll share what we're currently experimenting with. Second. Yeah, hopefully you can see it. So this is the part of Sofia where we took a piece of Sofia and we started connecting a representation of real objects. So as you can see, those are real objects that we want to be able to enrich with data and allow for remote inspection. So this is near, as I said, the ring road of Sofia, next to a substation. And here, for example, we have a situation with extreme rust. What we want to be able is to allow the people basically go there and also plan things like access, terrain, condition, something that is not present currently in our platform. So that was a very quick demonstration where we stand right now. So I'm welcoming anybody who wants to be a part of it, who have any further questions, to contact me. This is my email. And basically reach out. Ideas. We're looking for developers. We're looking for data science engineers. So if you have any idea how to connect this to Azure, I'll be very happy to get in touch with you and answer that. And that concludes my presentation. Thank you.
These days, if you don't have an app, you're falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.